start. Good morning, everyone. Welcome, everyone from online and also physically present here. First thing first, I express my sincere thanks to AWA. First thing, award me Water Professional of the Year for New South Wales, and also give us opportunity to sit down and talk together. And thanks, Katie and Nicola. Plenty of help to set up all the scene. And opening, I'm going to talk a few things. Through the session, you will have opportunity to ask questions to our presenters. Simply click on the chat option on the top of the right-hand corner for those people who are joining by webinar. Of course, people here, it's much easier, but I would suggest that we give the opportunities to people offsite first, and then we still have plenty of a catch-up session after this, if you want. And when you send your questions, just type in your question. Be sure to post it to everyone so that the team here can see it and collect and ask. So Katie will be in charge person and file the questions up. If you have any technical issues, please initially refer to the cheat sheet in your registration email to check your system is working correctly. If you continue to experience issues, please send a message in the chat box again to everyone so that our team here can collect, and we will see what we can do to help. If anything happens not according to the plan, we are recording this session, so you will have the chance to get the link, review it afterwards. So any questions? Any issues? No? One thing I should mention is the exit. So for any file or any emergency, there's a few staff members, follow them. they will find the closest exit, and then you just follow them. Okay? So let me open the whole talk, which will be shared between me, Lucinda, and Damika. They're both coming from NSW Water. So the sequence is I'm going to give a very brief opening to set the overall data and analytics as a scene, and then I will pass to Lucinda to talk about NSW Water strategy overview, and I will come back to talk some of the when, why, how outcomes benefit on data analytics, and then pass to Damika to give case studies. And most of the question time reserved at the end. But if you have a pressing issue of the thinking, it's fine. I mean, we're always happy to accommodate. Okay, time-wise, we're okay. So we're supposed to have 10 minutes. So 5 minutes ahead of time. Let me start. Okay. Overall today, we try to share that our learnings, our experience, our journeys on data-driven research innovations for water industry. Before I open that, actually, I want to share one slide. This is not my slides. This is, I cheated from McKinsey. And then the things I wanted to draw your attention is in order to understand that this is the theme is talking about the benefits to industry. So they list the lot of industry on the left-hand side, and the x-axis was talking about the overall ease of capture index, which is the first column with the colors. The second one is the talent, whether you have the talent in the industry. And next one is the IT intensity. Next one is data-driven mindsets, and the last one is data availability. So from this one, it's not exclusive, but you know that things need to come together to make things happen in particular industry. So I try to, the color means, so dark the color means availability is higher. Okay, I draw your attention to the last line, which is utility. So you can see utility overall index is very dark, which is hooray. It's everyone think the guys working in this one, really. And then particularly you're talking about the last two, which is the data-driven mindsets. Hooray, big tick, and then data availability. Even though I work a lot utilities, people keep asking me whether my data is enough, whether my data is crap. I think if you look at the chart, you should be proud of the whole industry. You're doing good. Okay. Next one, very quickly, is for the asset management or overall in utilities in the industry. Right-hand side lists some of the examples of the data you already collected or the data you can get from somewhere. For example, for the asset registry, you have all these mature age pipes, all those things. Majority of the utilities have them. And a lot of environmental data is available now, like the temperature or rainfall, wind, all those ones. You can easily get it from BOM, and soil moisture, all those ones as well. And then the other thing is you collect a lot of past history, like your failure history, your chemical dosing, your energy use, whatsoever. It's reside in utilities in maybe different functions, different sectors, but it's in the company. And the last thing is a lot of dynamics, which should be considered as well, like your pressure, or some of the operational characteristics, which a lot of them hasn't been used in real time. Of course, you set a portfolio, run some analysis, get some understanding, and then just use as is, maybe 5 years, maybe 10 years, I don't know. But this is worthwhile to think, to consider more in the real time. And left-hand side, talking about the challenges, could be so infrastructure is getting aging, they're getting older, not younger, and budget-wise is getting more constrained, not to have more money. So all those things, population is growing, and then the challenge to us is how can we do things smarter. So there's a lot of applications from the data analytics to various different industry. Water or utilities is one of them. Other ones like transport and telco and gas and oil, all those ones. If you guys are interested in, I'm more than happy to talk afterwards. So we do have work involved in majority of the industry's different sectors. And last thing to talk about, if we drill down into what the data can do in utilities, apart from asset management, it can apply for demand analysis, different behavior networks, and we're going to go through some of the studies afterwards. And so, last slide before I pass to Lucinda is data-driven solutions. What do? You do smart predictions, risk evaluation assessment, performance optimization, decision support, infrastructure, blah, 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 all those ones. And from 2011, so about 5 years, starting from Sydney Water, thanks very much for the great lead and the support, lead us into this area. And then we work with the Sydney Water significantly. And from that on, we also worked with other 20-odd utilities, worked along on the pipe failure prediction perspective. We have dealt with more than 9 million pipes, about 700,000 failure records around the world. So we will give more details later on. Let me pass this to Lucinda. Maybe you give one. Yeah, this one. Yeah, this one. That's this one. Yeah, maybe you wanted to introduce yourself.
Yep.
Yes.
I'm Lucinda Monsell from Sydney Water, and I manage the strategic analytics team. So it's a great opportunity to be here today amongst people with such a diverse range of experience and in an environment that really opens our mind to what's possible with data-driven innovation. So what I'm going to do is just give you a brief overview of our data-driven innovation journey and some of the lessons that we've learnt to date. So Sydney Water is the custodian of nearly $6 billion worth of infrastructure. And if you laid our pipe network end to end, it'd be nearly 3 times the distance from Sydney to London. So we're really interested in asset management, but our strategic focus has shifted to putting customers at the heart of everything we do. So to better understand our customers and to give them better customer experience, it was acknowledged that we needed to improve our analytics capability. So to think about how we were going to lift analytical capability within our organisation, we spoke to lots of people, like within our organisation, the private sector, research organisations and other industries. And we started to get some consistent messages coming back from them. And that was that we needed to focus on a number of elements equally. So when it came to leadership, we needed to take an enterprise approach, and we needed visible management buy-in, but we weren't to underestimate the benefits of building an analytics culture. Our priorities, they needed to be strategically aligned, and we needed to focus on areas where we could reduce uncertainty, because when it came to analytics, that's where we were going to get our greatest benefits. We needed to utilise people with really diverse range of skills and then empower them. When it came to digital or IT, the key message was we needed a single platform, and we needed to be able to give as many people as possible access to as much data as possible. And with our data, good governance was very important, and having data fit for purpose, but the take home was don't let data quality stop you from starting. So the International Institute for Analytics said that some of the common pitfalls for organisations that are trying to build analytical capability is they normally pick on one or two elements at the expense of the others, and they're normally data and digital. And they also said often agencies tend to bite off too much, so they try to do too much at once. We also found that the word analytics meant different things to different people when we were talking to them. So I quite like this image. This is from the International Institute for Analytics, and it shows that analytics can range from just the interpretation of a graphic right through to the advanced predictive analytics and optimisation. So with Sydney Water's current level of capability, I think the focus for us is really leveraging our people and empowering them. So we need to provide them with the tools and the techniques so that they can undertake some form of analytics. And I think it's then that we'll start to see true enterprise data-driven innovation. And a wise man, Udo White, once said to me, Lucinda, you've got to really think about the value proposition you put into your staff. And he said, you've got to enable analytics, otherwise, and innovation, otherwise you're going to end up having to buy it. So when it comes to the advanced analytics, that's where we've got in-house capability, but that's when we look at partnering with people who are experts in their field. That's where our friends at Data61 come into the picture. So what we did is we married up the experts in Data61 in areas such as machine learning with people in Sydney Water who had years of industry experience, and it yielded some fantastic results. So I'll be handing over so that you can hear a little bit more from Fang about some of the techniques that we used, and then on to Damika, who's going to run through some of those collaborative projects.
Thanks, Lucinda. Yeah, it's very, very inspiring. And I actually can borrow this one for a second, which is most of the organizations, including utilities and the other industry I've been dealing with, more or less stay as a statistical analysis. That one has been very well adopted by majority of the industries. But how to moving the chain up, which is making the analysis be your friend to make decisions more and more real time and more according to the scenarios which exactly happening or happened right before. So a lot of things, you've done set the profile or some of the analysis, and they've been using that analysis as a guideline. to do the decision making. Maybe it's one step up to think about how to move the chain a bit up. That we will have a lot of benefit rather than create the 13th story water fountain. That's in Melbourne, by the way. So I can't touch my friends here. Okay. Before I start, actually, since Lucinda mentioned the buzzword of machine learning, so I wanted to just a little bit blurb about machine learning. Actually, machine learning group here is rated as a top one among the top five. Sorry, groups in the world, together with Google, Microsoft, all those big guys. So we are proud Australian, and we do have some capability in the house. I mean, in Australia. And for people who don't know where the 61 come from, if you go London or Singapore, anywhere, you try to call home, which number you dial. So that's where the 61 come from. Also, this is a prime number and the hex and whatever. So, you know, we're beating the jerk. So yeah, that's all good. And Data61, actually, we have about 1,100 people and plenty of data scientists. And it's the primary data innovation group in Australia. And as I mentioned, we work not only in the utilities, but working in some other industries. Some recognition from AWA as appreciated in the beginning, and in transport, we won twice of ITS award, research award nationally. And give some of the thoughts what we can do of using the data and to the actual task. So I started from left-hand side, which is generically talking about problem or challenge or capability, which is okay. Most people wondering, okay, when I have lots of data, what I can do. First step, I think the first step first is understand you have a whole bunch of data and you have something which is called outcome, or something you wanted to estimate, or you want to understand the links between these and a whole bunch of data, which we call factor analysis, which is you try to link various different data sets with some of the outcome. And the second one, anomaly. So you understand what's the normal behavior from these whole data sets, and then you try to differentiate some of them as abnormal. Next one, of course, failure prediction or any kind of prediction, which is you try to look at whatever happened in the past and then learn that one and use that as some kind of rules of Bible to predict what's going to happen in the future. And the trend prediction is the same, but more longer term. So if you're talking about 1 year, what is going to happen, 10 years, 50 years, and then going from that one, and using a whole lot of them together as decision support. And the right-hand side is a machine learning technology or techniques, which I only listed a few of them which we're good at. We really specialize. We have patents, we have plenty of top-end publications, which is one of the jobs we do as a daily basis. So for example, Bayesian non-parametric. I'm going to repeat that buzzword in my coming slides, explain what it is. And then the other ones we call efficient large-scale inference. We are dealing with large scale of data sets. I can't claim all the data sets we're dealing with in utilities are big data, but it's a large amount of data. And then you try to get some of the knowledge from those one and do what we call inference, try to link them to some of the outcomes. And of course, there's some other things about your data quality. We call sparse in the imbalanced data. Why is that? Okay, talking about the failure, even though there's some, headline stories about 13-story fountain, but if you looking at your total asset base, failure record is still very small amount of the whole data sets. So this is a sparse data problem. And then the other thing is we call imbalance. is you have one category and you have lots of data, the other one you probably have a little data. But when you do prediction, you try to predict each of the symptom or class. Then this imbalance and need some super good techniques to deal with. Otherwise, your learning may end up geared, very biased towards one class, not the other one. So it's a lot of challenges in these ones. That's why this superb machine learning capability kicks in to take lead of a lot of applications. And in the middle, which Damika is going to go through majority of them, I won't steal his slides, but I can just mention the names, like the project we've gone through, the water main failure prediction, soil corrosion prediction, intelligent network, wastewater blockage, wastewater pipe blockage prediction, demand analysis, and active leak detection. So I leave to Damika to talk about the details afterwards. And then what I want to illustrate here is kind of the process of engaging, make the group of data science work with the domain experts. I don't think one way or the other can work, is because it's a joint work groups to link the circle. So you have a domain data, you have an expert, have a fantastic engineering or domain, whatever expertise together, and then that will help with some of the data cleaning, processing, because we understand some of the abnormalities is actually the data error, is not the symptom, right? So this kind of thing is a joint work. And then after that, we plot the data, and then of course some smarts kick in, machine learning, and then visualize in a way people can understand. And then this is another serious interactive work process to validate whether stuff machine learning or machine find is relevant to the root cause. So sometimes I call correlation not the causality. So correlation can show something symptom very highly correlated, but not necessarily caused by this set of data or factors. So this work needs to be done, collaboratively, and then eventually get feedback and how to tune this one, make it work, make it as an everyday exercise. And we have gone through that significantly with Sydney Water, with the support, and then hopefully we all find is a fun exercise. That's what I believe. And let me move into only one thing I would like to talk to is in the water main failure prediction. And there are some slides in Damika's one as a case, but in general, the problem I already defined a little bit. One is water main failure. If you look at the cause or factors will influence the water main, you will find a lot. Everyone can give you a story of one particular piece of pipe is failed because 1, 2, 3. So looking at those ones, so you in general have 3 type of factors. One is attributes, pipe attributes itself. So you have you have a material coating size, all those ones. And in those ones, there are subsets. For example, the pipes laid during the World War II may have a much higher failure rate, or blah blah blah. That depends on different utilities, different geographical region as well. The second set is the environmental, like a soil, weather, even could be bacterial mold or whatever, those kind of a thing. The third one, which is the operational, like a pressure, like a traffic loading, all those things. So many factors. So as take a Sydney Water example, it's more than 20 factors. Then you need some really smart technology to figure out this whole bunch of 20 relevant to one thing, right? And then I already talked about sparse, all those issues. And the solution we eventually figure out is in the middle. We call them Bayesian non-parametric. So non-parametric doesn't mean you don't use parameters. You use parameters. You just don't set the assumptions of the parameters. So the top one is parametric. Parametric methods normally like you have all these statistical plot, and then you try to draw the line, which is the red line. You see that? Red line is try to do the best simple language is curve fitting. So you try to fit the curve with your statistic and use that curve as a trend. And say, okay, if I'm going to do the prediction, if you see this one is yellow bar here. Ooh, where's my? Yeah, I can't see my mouse over there. It's just the fourth bar from the right hand side. If you can pick up the yellow color, that's the pipe laid in. So that's 85 years old pipe. You can see that one missed out with the red line a lot, but of course some of them meet well. So using non-parametric illustrated in the ways that this is only one dimension, one factor, is try to adjust the up and down accordingly. And considering if you have 20 of these different non-parametric charts, and then we can't do it, machine can do it, can calculate the relevance and try to plot the shape as much as closer to the reality. So that's the difference. And of course, we filed patents, all those ones, and the publications. If you want to, I'm more than happy to say. The email is on the list, and sending me email, I'm more than happy to share with you all the publications. It's in the public domain anyway. So both in the utilities like a water conference like LISM, IWA, all those conference, also water, and also in the domain of machine learning, so science, computer science, that domain. Okay, and the last, the bottom one was talking to another process which is called a non-homogeneous stochastic point process, and those ones are more for the long-term prediction. It's you have lots of events, especially for, so take a pipe as example. After first failure, and then your chance of have second, third, all those ones is becoming more frequent, right? So that's a typical kind of a stochastic point process can deal with. The point I'm trying to make here is the machine learning is a big category of a lot of methodologies associated with this one, same as when people talking about IT almost including everything. So, but with the different specific problem, you look at your data, you probably will find few effective solution can be applied. And yeah, of course, this is our job, our capability, and we've been playing live and breathe in this field for a long time. So happy to talk, to share whatever we can share. And then, of course, in the asset management domain, and then also in other analytics domain, there's plenty of products and competition as well. I'm not trying to say who's good or who's bad. The shoes is your shoes. Whatever problem that you can find the right shoes to solve, that's all good, right? So even we compare with our own software. So Palms was a part of the CSO's invention, and now of course that group is no longer with CSO, but I mean that's our brothers and sisters. So I'm going to talk a little bit in terms of how you compare the performance when you do your algorithms in the coming slides. But competition is not key. I think the find the right solution for your problem is the key. And failure prediction. So the sequence of failure prediction, eventually you want to lead to cost reduction, but the starting point is you understand your data, you understand your association of variable different data sets with your problem, and they try to build up some kind of prediction model, no matter whichever methods you use. that's you end up with called likelihood or probability. And then from that on, you're going to take in some of the other consideration in terms of cost, for example, the consequences, and it could be, when you try to dig out one pipe, you better have a look at the shutdown block. All those considerations, you can put them together, and then overall have a risk analysis, and then you can plot some of the optimization afterwards, which is consider your end goal. End goal is a service, maintain your service level, or your end goal is have you may use your money wisely. I got a extra $1 million money and use that. Which one I consider renew or dig out, which give me the best benefit. And so this one shows you some of the I call performance. The way to plot this chart is, okay, the x-axis is percentage of the network, which inspected probably is the wrong word. It's we use part of the data to train the model. Let's say we use data from 1998 up to 2010 as we call training data. We build the model, and then we try to test 2011, 12 onwards. That's one of the beauty of the data science and the data analytics, because you can hide part of the data and test a year-on-year basis and see how accurate it is. So this graph is showing that one. So you assume, let's just take this, for example, if it's 2015 prediction, we use the data up to 2014, and then check it through, okay, up to very hard to sorry for the people on not here. So for example, if you take 20%, okay, this is a 20, you test the 20% of your network and see how many failures you can find and the prediction can find. This is standard methods, is roughly about 20 something, and then that's our methods. And then this sort of envelope is all the 27 utilities data. So some of them is a bit lower, some of them a bit higher, but if this is the average. So you talk average, it's far better in that sense. So, and also through the exercise you learn. You learn, you know which one have more predictive power, which one has less predictive power. You have more data from various utilities, and also from one single utility. You keep pushing that curve more steep. So more steep means you look into most of the utility. Probably you can look into 1% or 2% or whatever. Very towards the corner, and if you can steep up that curve, that will give you much better benefit. And then this is some Australian context. Australian overall somehow spent couple billions in terms of renewal. In terms of fixing the burst water pipe, and if you can push that down towards more predictive, more preventive, that will reduce significantly on the social, economic, all those costs. If you damage or flood less properties, for example, flood less roads, and what you pay is only the minimum pipe repair part, that part, not the consequence cost. So yeah, I got a friend from Deloitte here. I was talking, so this is a report coming from Deloitte Access Economics 2015, and then they give us estimation. Actually, government commissioned them to audit us. So that's coming out of the auditing report, which says it can save about 300 million by this simple technology for Australia. Of course, I was talking to Malcolm Turnbull, try to explain. See, there's a broken pipe supplied by Sydney Water. They give us a much bigger pipe. We struggle to say, like, we send 6 men to carry a big pipe, or we just have one person to carry a small one as a demonstration. So there you go. And from that on, actually working with Sydney Water and other utilities, we already have real-time prediction software. I'm not going to talk here, but in the lab session afterwards, we will show you how it works. And sorry for the online audience, but if you're interested, I'm more than happy to organize some WebEx session after, individually.
I have one question.
Yes.
The graph of X-byte prediction versus industry standard prediction. Obviously, the X-byte line is very steep, but is there ever a problem of over-prediction of failures?
This is a very good question.
Can I answer?
Oh, can you? Yeah. Jump in.
This is based on data analytics and based on comparing historical data, training the model, and then using the future data to predict the model. Until we do an implementation stage, we will not know that answer, and we are planning to do that, and we have already signed up not only Data61, but the 3 leading universities are working on the bottom-up approach of understanding pipes, and that work has already started. I think we would be perhaps likely to, I think the word is more targeting and ensuring that the customers' impacts will be minimized. That's our water industry requirements to improve customer service. If there's an over-prediction in a year, we can most probably learn from that and improve that in the next year. So it's a learning exercise.
Thanks, Damika. And I add on some of my data scientist answer to that one. The question is about false positive and false negative. I think this is a hard question, but normally we give you a decision support, which is give you a list of probabilities in terms of where is the cutoff line. This is coming together with domain expert. For example, I give you top 1,000 pipes or top 100 pipes, and you look at the number 99 is a 0.11 probability. You can make your call judgment whether this one worth to do something or not to do something, right? So that's give you a tool to support you to make decision, but eventually you have the judgment call.
Sorry.
Yes.
Can I ask a question based on the explanation? Have you started using this to predict failures, or this is just a model and you're just exploring how best to make it as a part of day-to-day work at Sydney Water? So
it's a good question, and I'll perhaps answer it more in my part of it. Changing people's way of doing things from what they've done historically is part of the implementation stage. So I'll continue that discussion.
Okay, so it's over to you anyway.
Yeah, my presentation will obviously highlight some of the examples that Fang highlighted. I'm the Asset Infrastructure Research Coordinator for Sydney Water. I do work across the organization, and not only within the organization, externally, outside the organization, and we engage with the relevant expertise to get the best outcome for our customers. So data analytics is one aspect of that. So the presentation will include a couple of case studies and why we did it, what we have achieved up to now, what was the research about, and what we are planning to progress, which is a couple of the questions that have already been asked. I will talk of the Australian water infrastructure aspects. We have about 80 regional, local utilities, mostly members, all are members nearly of the Water Supply Services Association of Australia, our peak water industry body. We have about 140,000 kilometers of buried water pipes worth about $80 billion. You will have different figures the way accountants calculate this. Relied can advise us further on that. But most of them in the larger cities are very close to 100 years, especially Melbourne and Sydney are like that. Well, you need not stop there. If you go to London and UK, cities it is similar. We have about $5 billion worth of buried assets around UK, USA and Australia. So it is not only a problem for us, it is a problem for all water industry partners. The impact, if we don't do well, we continue to have main breaks of significant nature. We have about 7,000 main breaks per year around Australia. The rectification is quite expensive. It can be a minor rectification for a smaller main, a couple of $100,000 and $200,000 for a sort of a reasonable big one, up to about $1 million, including the disruption to traffic that you have seen in the harbour bridge and somewhere in Homebush. And the main break will be here in Redfern, but you see the flow-on effects. The cost of preventing a repair is quite significantly attractive, and that's why we as a water industry consider this as a significant issue that we should innovate and do better. Sydney Water itself invests $30 million in critical water pipes, $30 million in small water pipes, $30 million in maintaining these pipes, and another $4 to $5 million in managing those major events that we have per year. So nearly $100 million worth of effort every year. We have about 6,500 to 7,000 main breaks and leaks per year, out of which 60% of that are main breaks, which is about 4,500 or 4,200, which is about 10 to 15 pages for the senior manager who manages, the general manager who manages every day, night and day. Out of which the significant ones are about 165 failures per year. This year it has been less, which is about 1 or 2 per year, out of which about 10 embarrasses us, and about 5 is significantly politically sensitive. That is why this is important. That is why we need to do more than understanding of assets. We need to capture the right data and look at the data and try to predict what we could do better. This is just a visual image of an old picture. I think this is up to 2012. The main breaks, the red ones are the main breaks of the critical nature. The blue ones are the smaller mains, mainly in the CBD area, not the whole of Sydney. So it is a significant issue. This demonstrates it is a customer issue, a shareholder issue, and a regulatory issue. It's not only an asset issue. So it's important that we manage those 3 expectations, in some sense.
Can you say one word? The back colour is soil. So you see different colour? That's the soil type, different soil type.
I didn't mention that purposely because those are soil colours very broadly. We need better than that for pipes. So that's why I didn't mention that. For us, as domain experts, we want better soil data. In relation to prediction, I think this graph was presented quite well before. What we do condition assessment is only about 2% of our mains. But even as Sydney Water, one of the world leading critical water main strategy managers we have in Sydney Water, but we also do only 2% of the mains. And we put all the mains together and look at it. By doing that, we don't analyze the cohorts, which means that we don't look at the 300 millimeter, 400 millimeter, 500 millimeter, 600 millimeter and target them. That is one of the changes that we are trying to get the paradigm shift within Sydney Water, and also telling the researchers to look at it differently. If you look at the left-hand corner of this graph, if you look at the 2%, that's where we get the maximum benefit of doing something like this. So we get the maximum benefit not when it goes to measuring all the pipes, 100% of the pipes. It's only 2% we do. At that 2%, using data analytics gives us the opportunity to target where we should be doing condition assessment. This is not predictive failure. This is telling us where to look to get more data so that we can better target, and we can then analyze our assets in a way that is more effective, so we can then prepare ourselves to renew the pipes where it has to be renewed before it fails. That's what the data is going to tell. Moving away from the pipes, to another area where we found Data61. While I mentioned Data61, one thing that CSIRO Data61 didn't mention was that open up symbol on the right hand corner. Your CEO mentioned that is because you open up for collaboration and partnership. That is a message for CSIRO members who have joined Data61, and also a message for the water industry and the peak bodies like the AWA and the WASA. It is a collaborative partnership that we have. And this is partnered with Sydney Water with that spirit, the system optimization, because there's an optimization team within data analytics in addition to machine learning that has demonstrated outcomes, not in the water area, but in other areas. So what we did with this is we selected the Warnora system, and we are looking at how we can optimize the water quality. Warnora is a system that has minimum pumping, it is more gravity. We have a large pipeline that supplies Engadine from the Warnora Veolia Dam. Eve is here from the Veolia water industry here. Engadine is pumping, but then after that is basically gravity that goes through the system. So what we do plan to do with this data analytics to see whether we can optimize our secondary dosing we do for a chloraminated system. This is a chloraminated system that we add chlorine and ammonia together to ensure that we get the residual chlorine to the end of the system. But how can we get a better system optimization to provide better water quality to our customers? We have been talking to Washington DC, and that's why I mentioned that open symbol, in relation to demonstrating that they have smart meters, we don't have smart meters, whether we can be working with them to exchange that smart metadata, and say not looking at the customer aspect only, but looking at the system information so that we can bring back more value to the customers. The outcome of this work will ensure that we will have better certainty in the prediction of water quality. We may improve our energy optimization. We will improve our reservoir dosing capability. We are now implementing online reservoir dosing capability as a pilot, and we will implement it all along our reservoirs, how we can improve that. We can also look at opportunities where we have loss of water in the system. I know we have Suez here who's doing the similar work. This is an opportunity while we are looking at number of parameters. When Data61 took over this work, they were focusing on water quality, but I told them last week that you are going to deliver more because you're looking at parameters that look at other factors. I'll give you another example. When you target an innovation, you have to look at a lot of factors. And when you understand and look at factors by looking at the way we understand the data analytics through the machine learning expertise, as then we open up the domain people and they start thinking differently. So getting these two teams to work together brings you outcomes along the way that you are not expected. So we want to move from the research and innovation phase to the implementation phase much quicker. And then we will, I think, certainly get all the outcomes that are listed on the right side.
Really appreciate it, Damika, always working with the hammer. And then we push our learning curve very steep. Good.
The other more soft example that Lucinda led from the data analytics group was that we have people in data analytics that didn't believe in machine learning. This is a small example strategically Lucinda picked up for two reasons. One is that to demonstrate to our organization and to our customers that we are also considering understanding customer behavior through machine learning techniques, and also to get our people engaged in a way that where they didn't believe that machine learning will work because they don't work on equations that are known, there is no assumptions, there is no understanding of the water pipes or the other means of analytics that we have done for nearly 100 years. So opening them up, this gave an opportunity to the analytics team to say there's another world that we can open up. So one is the customer segmentation, the behavior patterns that we were able to demonstrate that this method can do. The other aspect is getting of the learning and getting our people behind looking at different ways of looking at data. Another area that we actually took some time to kick this off because people say, we do that well. Why do we want to do this again? We look at our nearly about 20,000 kilometers of pipelines every 3 years, like around 8,000 every year. We go and get contractors to go and look at small pipelines. Again, you are very well aware that this is happening not only here, but in overseas countries also. The difference in Australia and in Sydney Water is our non-revenue water or the leaks are very little. It is not much. So we have evidence of that, but we still want to ensure we do better by our customers. We also want to prioritize our efforts so that with the restrictions we have on operational and capital money, we need to ensure that we do this better. Also, leaks can move into breaks. So that's another area that we should be looking at. We have done small pipe, which you will not see a slide today, similar to the leaks here on small pipes. We did a research project with Sydney Water, and if you overlay the small pipes onto these leaks, prioritization of areas, you will see some similarities in relation to where we will need to focus our leak detection program. There are large gravity zones that we have basically in the Potts Hill, which is on Bankstown, that area, that we don't have a way of planning where we should be looking at. Pressure zones are a little bit easier to plan, you know better than me. So that has given us an opportunity to perhaps demarcate within the gravity zones where we should be prioritized. And this is ongoing research as we speak. And this has also got the people who have been dealing with leakage to think differently in where they are progressing. This is quite a challenging exercise on looking at sewer corrosion. This is on concrete corrosion. We have ourselves, we have Melbourne Water, we have about 900 kilometers of concrete mains. Melbourne has about 300 kilometers, SA Water perhaps around 100. Water Corporation line their mains with plastic, but they're still interested what's happening underneath the plastic. So they are working with us in this space to understand that. It is expensive. We don't have many, but it's expensive. We spend about $45 million in relation to renewal of concrete mains by touching them and walking through them. There's no other means of doing it currently. We spend another $5 million of dosing chemicals by looking at modeling tools we have currently. So we put $50 million on capital money on managing our concrete sewers. Melbourne does about 10 to 15 million over 3 years, and perhaps 5 million for about SA Water, in 2 to 3 years. So that's why we are together, collaborating and working together in understanding how we can prioritize corrosion in sewers. By doing that, we have also been able, that's where we are targeting. We haven't got that yet. I haven't pushed you to get that yet because there is some more time left, months, not years. But while we are trying to achieve where we should be targeting in our southern and the northern sewers, you might see if you're traveling around the airport, our sewer lines being visible on the top. You might see some vents around there also. So these are the sewers we are working on. We have a significant issue on our sewers on finding out where we should be targeting our effort. This is about targeting where we should put our effort. When we have done the work we have done with the ARC linkage with University of Newcastle, they are partnering this, and University of Technology is partnering this. So the Newcastle University will then tell us how to look at inwards into the corrosion rate modeling, and UTS is developing some innovative monitoring techniques to look at the surface humidity and the surface temperature, which is very difficult to monitor. Moisture, which is very, very difficult to monitor in a sewer condition. Macquarie is doing another project on using photonics. So it is an area that Sydney Water is very keen. It's an area that if you have not only concrete sewers, but manholes and concrete structures, that you are welcome to learn from us on moving forward. So this is a model that we were able to do. This was not an outcome, but this is one of the factors they had to do on H2S. Hydrogen sulfide is a key factor for corrosion. And while we were looking at the hydrogen sulfide data, which we monitored better than the other data we have in the sewers, we were able to develop a model. A model is now available on a conceptual basis to model H2S in a sewer network. We'll also develop a similar model for chemical dosing that we are working with our domain experts to ensure that we have a chemical dosing control system or a modeling system in place to dose what chemicals for what purpose, not on flow only. This was a surprise to all of us. We have used number of consultants, IBM and others, to come and have a look at how we can predict chokes. It was a challenge that Lucinda took up. Our organization had given up using different, there's a serious environmental issue with the EPA and others on chokes, which is related to overflows eventually in some indirect way. So the attempt was, okay, let's put a challenge up to Data61 to see whether you can model the chokes. So this is one of the recent successes or the recent success stories we've had over the last 6 months. On the right hand side, we can see the roots, grease, debris, another aspect that could cause. And what we have been able to do by systematically looking at this data in the pipes and environmental aspects, we have now a conceptual model, and we've actually learned on the other aspects of the critical water mains and small water mains that we have done by utilizing the data analytics much more. So it's a learning exercise for Data61 also, to be able to develop some maps as well as priority areas, and you can see in the bottom a quick snapshot how they've been able to predict. Again, this is prediction against the data, a high hidden data set. We need to really do an implementation stage to get our people to move with us and work with us to ensure that we can prove that it is actually chokes that they can predict.
Yeah, as far as I know that you guys are scoping up a trial on that at the moment, which is good.
All right?
Yes.
That's basically completes my part of the case studies.
I guess, thank you for all the presenters, including myself. And we're now open for questions. Maybe we start from...
I don't have any yet, so if we want to start from around the room. David.
Oh, huge data issues in all this. Yeah, everything I see is very data. How are you dealing with the data side of it, the big data? That's probably a Sydney Water question, but it's across both.
Do you want to start first?
In relation to the data, in relation to the asset management area, for example, the pipes, I think we have got quite well our data set for the last 10 years, and perhaps we are again leading in the world in that sense. And others are catching up very quickly. They are very much behind us because WASA has done a lot of work in this space, and so has UKWR. Perhaps USA is a little bit behind in relation to capturing the data. But in relation to breaks and leaks and breaks, we are pretty well equipped to capture the data. And maybe with the data platform, you may be able to tell us what we're
Well, I suppose, it's a learning journey for us. So we're fairly immature when it comes to, I would say, data management. So we're at the start where we're looking at data governance, setting up data governance councils, standards, and it's a very long and expensive process where you've had systems that don't talk to each other to start to integrate those, and so that's where we're talking about the prioritisation linking to strategy, trying to pick them off bit by bit and in the areas that matter most.
And from my learning perspective, I think all data coming from utilities, they have all data, but just residing in different system, which is how to extract them out. The only exceptional one is the environmental one.
Right.
For example, the weather data. And then in the last project Dominic mentioned is the sewer choke. Actually, we used the image of the trace. So this one is not traditionally reside in utilities, but it is generated through all kinds of things.
I think we very much rely on domain experts. So like in the industry itself, we've got people that have been around for a long time with a lot of experience. So when we're acquiring the data, we're relying on key individuals to extract it and then who understand it too. So that understand the intricacies and things that aren't quite right, and we rely very much on those people to work with Data61 when they're interpreting it, until we get to the point where the data is easily understood by all and easily extracted.
That just remind me that in the talk, the starting point is we write on the whiteboard like a 10-ish people coming from Sydney Water, various different operations or research or whatever. We're just brainstorming what the data they actually have.
I think another thing you need to answer that question is, who does it always? Big data is not required. Data is what is required. That's the basic method. You may need to explain more, but that's my plain English learning of that.
Yeah, we don't have a big data problem. Yeah, not what he was trying to say is that not necessarily you have to have large quantity of the data, but you have to capture all the variety. That's probably more important. And I mean, variety in terms of your changes in one data stream, or you have multiple data streams. So you try to collect samples of those multiple ones, even though just some sample. Yeah.
Hi, Paul Banfield from Suez. A lot of discussion about number crunching and bringing lots of data sets together. But when putting together prioritization and strategies, consequential impacts is a major factor, which is has less data available. What sort of research or focus is there in coming up with consequential inputs to this process?
You want to talk first?
In relation to consequences, you're talking of consequences to our customers, or are you talking the
Financial consequence or customer consequence? So that's one of the two fundamental base. Which is more important, financial consequence or customer consequence?
We have done a study about 5 years ago on the pipe area, which I think needs updating. There is resistance to update it on an asset management basis, thinking that we know these things. But when a Dalwich-Hill main fails, and it's not considered to be a high-risk main because the consequence was considered to be less because it's in a road, but if it is in topography is that it floods 20 houses in 5 minutes, how did we miss that? So I think the exercise of an implementation stage is to take the people with us. And as Lucinda was telling, we have an educational learning process by understanding data as well as the consequences. If we are customer-centric, our mindset has to change. And that's, I think, possibly where we are at now currently. We are changing our mindset to say, what is the consequence and what is the impact to our customers, and why we should be doing this is because we need to get that right.
Yeah, very important question. And I think depends on areas. So in the water main failure, so Sydney Water has a very detailed, still yet to update its economic model, which listed the calculated the consequence for each of the types, and then we've done that work, combine the consequence with probability and making decisions or support decision making. Other utilities been working with, they may not have exactly the numbers attached to each of the pipes, but they do have the table. Most of them have a table, 5 by 5 or whatever. Resolution. This is the base you can only rely on, but this is the learning curve, and they try to start something and they implement and then learn more, and even collect more data or identify more resolution in that way. You have a question, sorry, before. Yeah, go ahead.
So are there any attempts to capture the intuition from your domain experts in a numerical way to implement into these models?
Very good question. I don't think we will have the numerical ways. We now have a bit of knowledge in our mind, which probably needs to translate that more systematically into how to do things. And then we felt that we have done significantly quicker, close to our customer in the chalk or those recent ones. The early ones, even us, spend time learn how to work with domain expertise. So the answer is, good question. Yeah, watch out the space.
I think another answer is the paradigm shift. I think there is a step before the, getting a numerical sense of what the domain expertise is. We have to get the domain experts to understand the value proposition which was discussed at the beginning of this work. And if we can't demonstrate the value proposition after the investment we are putting in this, we will struggle. And that's why the data platform has been put up. That's why the digital transformation business is taking place in Sydney Water, to demonstrate that value chain to the customers through our people. So I think through that process we may have to get some indicators of performance through these projects to say what are the key indicators of certain data sets. I think we haven't thought through that yet. Possibly it is, we have used it, but we need to start looking at it a bit better.
I think another point to that would be that the practical application and the domain experts are picking up on what data in the future might increase the accuracy of prediction. So sensor data and the Internet of Things and the access to far more volume of data from measurements in the field should also be over time built back into these models. So I think that's an important piece of the learning that is going to be built back into it.
Okay, thanks. Just a couple of questions. What technologies have you used? Did you use SAS? Did you use Hadoop? Underlying for your modeling, what technologies did you use? How long did it take for you to run these 6 or 7 case studies, given the fact that it's in a pilot mode, you know, you're investigating, you're trying? Did you sample the data, or did you have a go at the full data sets in its entirety? I guess the change management becomes a part of your implementation, which I think will come in the future. So those are the key questions that I have.
You give me a heart attack, but I try to answer as much as you can. If I missed out, you just reiterate your questions. I think coming from a methodology perspective is that most important is what sort of data we deal with, and different data will lead to or require different methodology.
Okay.
And then, of course, we all are very familiar with, Spark, Hadoop, all those standard thing, but a speed to which most of the cases you find that the standard thing may not work. If that works, probably the problem was resolved a long time ago.
Yep.
That's what we found. And then the other thing is, of course, if this is a solution, for example, the demo we're trying to show you, that could be the SaaS application. That's it's not a showstopper for that one. And what
How long did it take?
How long did it take? This really varies, depends on how complicated the problem is. So starting point, like when we started from dealing with Sydney Water on critical water, that take us about
3 years.
Yeah, 2-3 years to really get to the point. But after you learn that one, dealing with the new data sets and utilities only take us weeks now. So that has been significantly shortened. And then also, if talking another issue as the whole intelligent network, you have the water quality, you have pumping, you have chemical dosing, you have all those different aspects, and then that makes hydraulic models very complicated. If it's isolate like a chalk one, it's relative. So it's still a complicated problem, but the complicated problem focused on one area that would be a lot quicker. So that a project in total, less than 6 months in total from day one, you scope stuff to you show the positive outcome. So.
And I think the key to that is in 6 months you'll get a result with the data you have, and you'll be able to take action and you'll learn from that. And what we're providing is a software platform that allows you to continue to use that data, update it with more failure records as they come in. So it's an ongoing process.
It's a cousin principle. It evolves and it grows.
Exactly. Yeah. So the software becomes important as an element of building into day-to-day activity.
Go ahead.
In considering blockages, is there any overlapping of any data associated with trade waste or pre-treatment device characteristics?
It's young here?
You
No.
just said.
No. Okay, so I'll probably leave that question
Sure.
to refer back.
Okay.
Just as obviously all this is applied to the networks space at the moment, is there anything from a Sydney Water perspective being done looking at the treatment assets side? Because obviously a big problem we have is on the sort of capital delivery side of Sydney Water is that a lot of decisions are made on very loose assumptions. Well, that should go because it's 15 years old. whether it's working perfectly or not. It's not really a data-based decision-making. Well, at the moment, a lot of money is probably wasted as a result of it, I guess.
Yeah, I think there is, in the treatment space, in relation to treatability and in relation to the storage in the water side, in the wastewater side is a little more complex. We have started some work, we are planning to start some work. With the University of Sydney, we are commencing some of that work. We are looking at some of the work. We did a little bit of initial assessment with Veolia and the University of Sydney on the Woronora catchment and the initial overall top-down looking at the data within the plant. Not in detail, but I think we have to define what the problem is. And that is what that was picked up in the report. What Professor Hugh basically says, tell me what your problem is. Our issue was treatability. In that sense, when he looked at the data at a high level, there is no issue in Woronora because we are working well with him and we recover quickly after an event. But if any issues that has an impact that has to be looked at, the data analytics can again target like the pipes where we should be looking at. On the other hand, now people are working with the treatment people. Now one of the people who was in this industry is with the treatment people. They're developing more the traditional tools that has been used in the treatment exercise or innovating some of those traditional tools like computer fluid dynamics to look at filtration, which is quite novel, which has not been done before. So that is happening and that's been in place in our Nepean water treatment plant. But that's not data analytics, but some aspects of modeling with assumptions in relation to parametric modeling. But we are interested still to look at how that will interact with the sparse data environment like the catchment and storages and how it will impact our treatability. So we have started, there is scope to do it and there is challenges with it. So I think another couple of years of a journey perhaps of where we need to be. And we are all interested actually in Trinity. One of our partners like Suez and Veolia came to the table with some standard machine learning algorithms to say, and I was surprised that a water industry partner is coming to the table and saying we need to do this, and especially for treatment, because treatment is more conservative than pipes.
I think it's also the learning curve and gradually try to make more objective decision making than subjective. But this is a long journey. I mean, to avoid this making decision needs a lot of time and collect data, validate the trust some of the outcome, and gradually build change process. Tier 1, they probably more rely on the objective side than this side. Questions there?
That's all online.
Okay, I think the time-wise probably is here. I try to conclude here, but then we have left all those things for the people coming here, and then we can ask questions, whatever. Okay.
Would we be able to ask a question online here?
Sure. One last question. Go ahead. I'm sorry.
Good on you, Nick Thatcher from Esri Australia here. Just making sure I've got my head around this. Back on slide 26, there was a graph there sort of comparing the industry standard approach to X-Byte solution. So if I'm understanding this correctly, following the traditional sort of approach to predicting pipe breaks, if we look at that dashed green line there, you get 30%. So this is network inspections. If we had X dollars to invest in inspecting the network following traditional standard approach for prioritising inspections, you would find, say, 30% of the broken pipes. Now, using X-Byte solution as a tool to prioritise sort of inspections, you would find 60%. So this isn't talking about sort of direct pipe burst predictions. This is talking about prioritising maintenance and inspection activities. Is that right?
Yes. That's what I said before. Also, that this is a pathway and a process that we go through because pipe failure prediction has basically, we now say 4 key processes. One is data-driven prediction of where we should be looking at, which is what machine learning and this process has helped us. Then we go and select those pipes and do some soil-related preliminary measurements or investigations to understand, get more data. And then we pursue a little bit more with next level of condition assessment, the level 2 we call it. And if required, based on the interpretation and understanding the work that UTS has done on the larger project, we will then go and look at the internal pipes. Once that information is gathered, we will look at the corrosion aspect and develop or calibrate the corrosion model that Newcastle has developed, and we can then move towards a predictive failure model, which will be then really looking at telling us what pipe to remove when, and that is also along the pipe, which is another innovation outside this data analytics, but using machine learning again by UTS, we have developed that mechanism. So it is part of a larger set of solutions and investments that we have invested in the implementation stage.
Okay, thanks everyone. I understand there may have still have some questions haven't answered. I'm going to give you several bullets in a minute. So thanks everyone participate either here or online. Later on today, we will be sending an evaluation survey so that we can find out more about how you find the session. The survey will also have an opportunity for you to ask any further questions which may occur to you as you reflect on the session. We encourage you to complete the survey so that we know that how to organize those things better in future. So ensure that we build on success of events like hopefully this, and then continue to make improvements to get best value out of any future sessions. Thank you everyone online, and we conclude our webinar from here, and see you next time.
Thank you.